Hello, dear students. We start our lesson. Today's laboratory work by interchangeability, standardization, and technical measurements. Laboratory work number 5. Choose of fits of a spline connection with a rectangular profile. And let's read the task number 5 of this laboratory work. For splined connection with two thickness Z is equal 16, inner diameter small d is equal 72 millimeters. Outer diameter big D is equal 82 millimeters. To this B is equal 7 millimeters. With centering on B, it is necessary. It's very important. Centering on B. It is necessary. Select the tolerance fields and feet of shafts and bushings for the centering diameter and tooth flanks. Select tolerance fields for non-centering diameters. For the given dimensions of the spline connection and the selected tolerance and feet fields, give the symbols for the spline connection as well as separately for the bushing and shaft. And 5.4. Determine the numerical values of the limit deviations of the diameters of the hole and the shaft, the width of the hollows of the hole, and the thickness of the teeth of the shaft, and together with the tolerance fields, put them on the assembly drawing and drawings of the bushing and shaft. Please write down to your notes this task and this example of the task. You will have your task using your variant. But now you should write down this task, this variant of task. It's example. It's our example of calculating. If you finish this slide, we will continue. So it's the task. And now for spline connection with two thickness Z is equal 16, inner diameter small d is equal 72 millimeters, outer diameter big D 82 millimeters, tooth width B is equal 7 millimeters. With centering on B, choose the tolerance field and feet of splined shafts and bushness for centering parameters. So centering parameter is B. Choose the feet F8, JS7. Its tolerance field for the hole, for the bushing, and tolerance field for the shaft. Where we get these parameters. On the next slide, we can see the tables. Directory number 5. First tables, when centering on D. When centering on D. When centering on B. For non-centering diameters. So we should use and when centering on small d, we should use table when centering on B. And we can choose this parameter F8 and JS7. F8 for the hole or for the bushing, and JS7 for the shaft. For non-centering diameters, it's tolerance field for the B. Non-centering diameters, it's small d and big D. We can choose A11 for the shaft, and for the bushing, H11 for small d and H12 for big D. So on the previous slide, for B, we choose F8 and JS7. For non-centering diameter small d, we choose the feet. H11 is for the bushing and A11 for the shaft. For non-centering diameter, outer diameter, big D, is we choose the feet H12, A11. It's for the bushing, it's for the shaft. For the shaft, A11. You can see on the figure the parameters B, this type of connection, and outer diameter big D and inner diameter small d. It's inner diameter small d. So after that, when we choose the fits for all three parameters, for the inner diameter D, outer diameter big D, and tooth width B, we should continue our determination of the task. For the given size of the spindle connection and the selected tolerance fields, the symbol for the spline connection will look like this. Its centering parameter by B on the first place. 16 number of the teeth is 16. Inner diameter, small d, is equal 72 millimeters. For the small d, we choose the tolerance field H11, A11, as we can see in the previous slide. For the small d, H11, A11. For small d, H11, A11. For big D, H12, A11. So, it's small d, diameter 72, H11, A11, big D, diameter 82 millimeters, H12, A11, and B is equal 7 millimeters, width of tooth. And we have feet F8, it's for the bushing, and JS7 for the shaft. It's for the spline connection. The symbol of the spline connection. The symbol of the splined shaft. Only parameters for the shaft. H11 is parameters of the feet of the bushing. H12 of the bushing, because we can see H, big H. And it's above the line. All parameters above the line is for the whole, or in our case, it's for the bushing. So for the splined shaft, B, it's parameter of centering parameter. Number of teeth 16, small d 72 millimeters, and A11. A11, small A11, its parameters, tolerance field of the shaft on inner diameter 72 millimeters. Then outer diameter 82 millimeters, A11, again A11. So it's tolerance fields on in outer diameter of the shaft, and it's equal, this diameter is equal 82 millimeters. And this last place, it's B, it's equal 7 millimeters, and JS7, it's tolerance field of the shaft on the B, on the width of the tooth. Width is equal 7 millimeters, and tolerance field it's JS7. For the splined bushing, we use parameter only for bushing. H11, big H11, big H12, and big F8. On the first place, the centering parameter is B. 16, it's Z. Z is equal 16, it's number of teeth on this connection. In inner diameter 72, we have tolerance field H11. For outer diameter 82, we have tolerance field H12. And for B, we have tolerance field F8. So if you have the symbol of the spline connection, you can use this symbol to create the symbols of splined shaft and of splined bushing. Please write down to your notes these symbols of connections. And we are continue. Determine the numerical values of the limit deviations of the diameters of the hole and the shaft, the width of the hollows of the hole and the thickness of the teeth of the shaft, and together with the tolerance fields, put them on the assembly drawing and drawings of the bushing and shaft, like in figure 5.1. You can see figure 5.1. You should use the directories 1, 2 to choose for the fits the numerical values of the limits deviations, upper limit deviation and lower limit deviation for each tolerance field and each diameter and B, the width to the width. So, for example, B is equal 7. It's for the shaft. You can see first for the shaft. B it's tooth width 7. JS7 it's tolerance field 7. It's IT grade. Upper limit deviation plus 0.007, lower limit deviation minus 0.007. Inner diameter, diameter 72. A11, tolerance field A11. We use them directories and we can find that upper limit deviation of the shaft on this diameter, it's minus 0.360, and lower limit deviation is minus 0.550. For outer diameter, diameter 82, we have tolerance field A11 too, like for the inner diameter. So we can find the upper limit deviation and lower limit deviations, and upper limit deviation is equal minus 0.380 and lower limit deviation minus 0.600. It's all parameters for the shaft. Parameters for the bushing. We use the blue color. Parameters for the bushing. B it's equal 7. F8 it's tolerance field for the bushing on the parameter B. We use the directories and we can find that upper limit deviation of this tolerance field for diameter 7 is equal, for dimension 7, is equal plus 0.035. And 0.013. For the inner diameter 72. H11 it's tolerance field, and we can find that upper limit deviation it's plus 0.190 and lower limit deviation it's equal 0. For the outer diameter 82 and tolerance field H12, we can find that the upper limit deviation is equal plus 0.350 and lower limit deviation is equal 0. And for the connection of the shaft with the bashing. For the parameter B, B is equal 7, and we have the fit for the connection. We have tolerance fields for the fit F8, JS7. F8 is for the, for example, for the bashing. And JS7 for the shaft. And once more again, for the inner diameter, 72 millimeters. H11, A11, and for the outer diameter, 82 millimeters, H12, A12. So now you can calculate your variant of this task of laboratory work number 5. Use your variant of the task and calculate these parameters. You can see all points 5, 1, 5, 2, 5, 3, 5, 4. Please start calculating, and when you finish it, send it me to the Telegram group, to our course. Please start calculating.